Okay, so we're going to use our trend lines today on the graph. So if you will mark these two at the top, those are our vocabulary words we talked about yesterday, right? Trend line and line of best fit. Do they mean the same thing? Yeah. So that trend line is what we're looking at. And I do want you to mark one other thing. This one right here. Not all data points are going to be on the line. You may have 5 points on the line. You may not have any points on the line. Okay, and that's fine. So we're not trying to connect every single point because that's not going to make a line. So let's look at example A. What is example 1? What is this graph talking about here on example 1? Anthony's bank account. And where is his bank account going? Down. Which means he's getting less money. Okay, so if you look at the x-axis, what does the x-axis represent? Days. And what is it counting by? What is its scale? 10. And then the y-axis is his balance in dollars. That means how much money is in his bank account. Well, what is it counting by? It's not counting by 50s. We see 50s. What's in between 100 and 150? 125. So I'm going to go ahead and add that in there. Above 150 would be 175. This one is 225 and then 275. So we see 50s, but it's actually counting by 25. So we know we're talking about a bank account. We know the data is going down, which means his balance, the amount of money in his account, is going down over time. And it's important for you to understand what the graph is before you just start asking questions and answering them. So let's look at question 1. What is the correlation of this data? You got nothing? It's linear because that data is going down. And I heard somebody else say what? It's negative. Savannah, can you stop that, please? Thank you. So it's going down. It is negative. I want you to add in here, line is decreasing. Okay? That came up on a STAR test one year, and I had kids who were confused with what that meant. If the line is decreasing, that's the same thing as negative or going down. Now, do we have another word for correlation? Do we have any other words we use? Also called, we had 3 words. I don't know, they're on the previous page of your notes if you were to actually turn the page and go look. Seth, take your headphones out of your ear, please. We're 20 minutes into class. No one in the whole room can look on the previous page and see that the word trend is also association and correlation. So this is also called trend or association. So if you were to see that question and it was worded differently, it's the same thing. Trend, association, and correlation are all the same. Katie, you all right over there? Are you with us at all? Okay, just checking. All right, so the second question says, how much money does Anthony start with? When I'm talking about a linear function, I'm talking about what he's starting with. What is that? But like, not the number, not the answer, but what is a starting thing called in math? Y-intercept. The y-intercept. So start with, we're looking at the y-intercept. Now, say your answer again, Marley.
I guess like 280, just a little above 275.
So it's right here, above 275 and below 300. Okay, so we're looking at a range of information here. This is a best guess. And if it was a multiple choice question, you would look at your answers to pick the one you thought was best. So what do you guys think? Do you think 280 is good? 290, 285? What do we think? Yeah, I'd probably say closer to maybe 285 to 90-ish. So which one do you want to write? All right, so we're going to put about $285. Now, on a multiple choice problem, I would not give you 285 and 290 as an answer. Not on this question. That would be a little too specific, okay? So you should be able to pick the best answer. All right, now the next one. After how many days will he have $225? Is 225 an X value or a Y value?
Y.
So this is a Y value. So I need to go to my graph, and I want you to take a color, whatever color you have, and we're going to go to the Y-axis to 225, and we're going to trace it until we hit that line of best fit right there. And then what am I going to do? Go down. So after how many days will he have $225? About 25. Do we agree? Okay. Now again, if this was multiple choice, do you think I would have 25 and 26 as an answer? No. Could I have 25 and 21?
Yes.
Yeah, you should be able to determine between those two, but I wouldn't put 25 and 26. So about 25 days is my answer. All right, then the last one. After 46 days, how much money will Anthony have? So 46 days, is that an X or a Y?
X.
That's an X. So now, I'm going to use a different color. If you don't have a different color, that's fine. I'm going to go to the X-axis to 46 and trace up until I hit the line. So where would 46 be?
Just below 175.
In between the 40 and the 50, so about in the middle. You're one step ahead of me. And I'm going to hit that line, and I'm going to come over to there. So I did this one in green. What are you guys thinking here? It's right below 175. 160? I didn't hear what you said. We're below 175. So does 170 sound good?
Yeah.
Okay. So we could do that. We could say about $170. Okay, so what we did is we used our trend line to answer those questions to make our predictions, right? So turn the page. How does example 2 differ from example 1? It's positive, so that's one thing. What else? What you got, Marley?
Like, either on the line, like where the scatterplots are going,
Okay, so it looks different. Like, how does it look different? What you got?
well, there are two things. The scale and the example restarts at
Say the second one again.
example 3, the line starts at
So, how is this line? Look at this picture right here. Look up at the board. This line goes from here to here. This line went from here to here. And this one goes from here to here. How is that line different?
because it doesn't start on the line.
It doesn't start on the y-axis. Does it go all the way across the graph? No. So what do you think we should do? Make it go all the way across the graph. So you have a note card. You're going to use your note card. On star, you do not get to use a ruler, okay? So you will have scratch paper. You could have a note card. So we can take our note card and act like it's a ruler. And we can line it up and trace it so that our line goes all the way across the graph. Now, what is this graph talking about?
Attendance at school.
Okay, the number of people who are going to games, right? And what is the x-axis?
Elevation.
No, x-axis.
Oh.
Question 2.
Years.
Years since 1990. What does that mean?
1990 and above.
So this would be really 1990. What is 4 years since 1990? 1994, 1998. And that's tricky. So that x-axis is counting by, well, we see 4s, but what is it actually counting by? 2. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now the y-axis is what? Attendance. But what does it say with it?
Million.
So when it says 170, does it mean 170 people went to a game?
No.
170 million people went to a game. That's a lot. Now, what is the y-axis counting by? What do I see? From 130 to 170, what is that?
140.
That's 40. So I see 40, so it's really counting by 20. So what's 20 more than 130? 150. 20 more than 170? 190. And 20 more than 210? 230. Sometimes that's really helpful to have that filled in. Okay, so we've already talked about what is the trend or the association or the correlation here. Is it linear, nonlinear, or none?
Linear.
It's linear and it is positive. Good. And earlier we said on that negative the line was decreasing. So what could we say here? It's increasing. Okay. So it's a positive linear trend. Yes, ma'am.
On the test, if we just put positive linear and not the line is increasing, that will.
Yes, that's fine. This is, I'm just wanting you to see the vocabulary. So yeah, the answer, the trend is positive linear. Okay. That's just me trying to get you to see that those words all go together, mean the same thing. All right, so we need the approximate attendance in 1990. So 1990, is that an X value or a Y value? That's an X. So that means that X is 1990. Well, 900 or 1,990 is nowhere on here. Why is it the 0?
Because it's starting from 19.
Yeah, how many years after 1990 is 1990? 0. So really, my X is 0. I really just want to know what is the y-intercept. So I'm going to come over here to my y-intercept, and it is this coordinate point right there. It's between 130 and 150. What do you think?
148.
I don't know if it's that close to 150. 140, 145? What do you think?
I think it's 145.
Okay, so 145 people went to the game.
145 million.
Well, okay, 145 million. So I want you to look, because there's 2 ways to write this. One way is to write 145 and then put the word million next to it. The other way to write this is to write 145 million with the zeros. Okay? But if you put 145, is that the right answer? No, don't do that. 145 people and 145 million people are very different, right?
Yes.
Okay, and then last one on this. In 2007, about how many people attended the sports game? So 2007, is that an X or a Y? That's an X. So X is 2007, but what do we have to do to find it on the graph?
You have to count up from 1990.
Yeah, so could I subtract them?
Yes.
So minus 1990. What is 2007 minus 1990? 17. So I need to go on my graph and find when X is 17. That's what I'm looking for. So 17 would be between,
230 and 250.
so we go between 16 and 18, and then that when I carry it over, and you could use your note card if you wanted to help you draw straighter lines. It probably wouldn't be a bad idea. It's between 230, 250 50. So what do you think? 240. Does that sound good? All right, so 240. What? Million? Or you can write 240 million with the zeros. Either way is okay. Yes? You could do an exponent. So, okay, last example. So example 3, what is this graph talking about? Elevation during a hike. So what is the elevation doing? Going up. So where are they going? Up the mountain, right? And the x-axis is what? Time. So how many minutes they've been hiking, right? And what is it counting by?
15.
So we see the 30s, but it's really 15. So it's 0, 15. What's between 30 and 60?
45.
Okay. Between 60 and 90?
75.
And between 90 and 120? 105. And then what's that last one after 120? 135. Counting by 15s is kind of funky sometimes. All right, so that's our minutes that someone's been hiking. And then the y-axis would be elevation. So I see 1,000. So what would be halfway between that? Yeah, so we're really counting by 500. So it's 500. The next one is 1,500. And then 2,500. All right, what kind of association or trend or correlation are we looking at here? Yeah, positive linear or linear positive, however you want to write it. Again, that means my line is increasing. The data is increasing. It is going up. All right, so we just answered question 2 and 3. What is the scale of the graph for the x-axis? 15. Good. What is the scale of the y-axis? 500. All right, so let's look at 4 and 5. These are the ones that are going to make us think a little bit. So 4 says, in 3 hours, what is the hiker's approximate elevation? So this is time. Is that an x-axis or a y-axis? So does that mean that x is 3? No, why not?
Because it's
Ah.
3 hours.
So remember how we talked about the scale and all that's really important? Well, the labels on the graph are as well. So this is 3 hours, but the graph is in minutes. How do I turn 3 hours into minutes?
180 divided by 60.
How about 3 times 60, I think you were doing it backwards, is 180 minutes. Well, I see a problem here. What's the problem with the graph? It doesn't go that far. So this is the part of the problem that we really don't tend to enjoy. Okay? So first thing, let's come up to our graph. We've got to make it to 180 minutes, which is somewhere over here. Got any ideas? What? Count by 15s and keep going. Someone said extend the graph, extend the line. Does that sound good? Okay, so here's where the note card comes in really handy. If you take your note card and line it up to the bottom of that graph, you can trace these tick marks. See how I just made little marks on my note card? See my note card here? See how that matches those tick marks? And this is tricky, okay? But what you can do is come over here and line up a couple tick marks, and now I can make more tick marks on my paper that measure the same exact width as my graph. And then here's what else is helpful. If you will come to the top and do it again, do you see how I now have a dot at the top and the bottom? I can use my ruler, or in this case, my note card, and I can trace from dot to dot, and if I were you, I would trace it taller than what you need. And it's easier if you have a ruler, but we don't get a ruler when we take a STAR test. But when you have a ruler, you can't really make tick marks. So I added more lines. If anyone is confused, let me know and I'll come help you. Brianna, you awake? Did you make tick marks and draw lines on your paper? I didn't think so. Anybody confused? Now, the thing is we need lines going the other way as well. So, you can check your tick marks. Are they the same the other direction?
Yes.
So you can use the same little tick marks. They match up here. Sometimes they don't. Sometimes you need new tick marks. And you can come over here. Whoops. And if you line them up here, we can make more tick marks. This direction. There. And put some more over here, because we're going to probably have to go off the graph. Both directions, it looks like. And then I can connect all the way across. This is kind of a pain, right? Yeah. I do not enjoy this much. It is not my favorite. But, you gotta do it. Brown, are you doing this? I'm again going with the answer is no. Okay, so if you want, you can trace more grid lines with your graph like this. You don't really need all of them. It doesn't have to be perfect. But it needs to be pretty close in order to get the right answer. Okay, so then we need to extend the line. So let's go ahead and trace that line all the way across our new graph that we have created. Alright, so we know that this is 120. We need to get to 180. 135. So the next one would be 150. 165, and then 180. Okay, so that's my goal right here. I need to get to 180. So I'm going to trace that sucker up to my line, and then I'm going to trace that over I know this is 3,000, so this next one would be 3,500. So it's between 3,000 and 3,500. Who's got a good guess, they think? Say it again. 3,250. Did you have another one? 3,100. So, I mean, if I'm giving you a test, I'm probably not going to pick both of those answers to put as multiple choice. So should you be able to kind of finagle the right one out of your answers? Yeah, so I'm thinking that maybe it's like, I don't know, 3,200-ish, which is kind of in the middle of what you guys said. So you could write either one. It would be okay. So it's about, I'm going to write 3,200. 3,200 feet. Now that's tricky, and it's a pain, okay? You're not going to have a whole lot of questions like this. but you need to be able to look beyond the graph. And that note card, making these little tick marks right here on the note card really helps to create that graph to make it bigger. Okay. All right, the last question, then we're going to practice this for a little bit. What was the hiker's beginning elevation? Again, we see the word beginning. What does that mean? That's my y-intercept. So I can come up here to the graph. So it's between 500 and 1,000. What do you guys think? 700, 750? Okay, so we could say about 700 feet. And again, it's an approximation.